Hello, everybody. Good morning. It's my pleasure to present today the results of the Technical Committee 282, working on calcined clays as supplementary cementitious materials. I was a chair of the technical committee, and Manu Santaram from Madras was kindly accompanying me for during the work. Now I have to see how to move it. Doesn't work. I click here. I did. Okay. So during the last 10, 15 years, the cement industry has been under a lot of pressure about CO2 emissions. It's been all over in the press and everything. So the industry is really getting prepared for that. When you see the roadmap developed by the Global Cement and Concrete Association, they are targeting a net zero scenario by 2050. So they really need to act fast to reach that. Among the strategies, they have several strategies to lower carbon emissions, but also when you look at the use of supplementary cementitious materials to reduce the amount of clinker in cement, this is one of the most important measures that they are going to do. The problem is when we look at what we have today, we have several supplementary cementitious materials, some of them like fly ash and slag, their availability is declining, their price is increasing. And the others we have like limestone, natural porcelains, they are not so reactive like we would like, and therefore they do not enable very high clinker substitution rate. So we need to do something. When we look at the global availability of materials, the only materials that are available are scale compared to the production of Portland cement are limestone and calcined clay. So it makes sense to work with calcined clays, because also especially kaolinitic clays, which are the most reactive ones, they are widely distributed around the world. I mean, almost everywhere you go, you find these clays. But also, and this is very important, when you look at the reactivity of these clays, and you compare the reactivity using, for instance, the protocol R3, you realize that they are way more reactive. Even the worst calcined clays in terms of purity of kaolinite, they are better than any of the other CMs that we have been dealing with in the last few years. So there's a good chance to increase the clinker substitution rate if we use these materials. So there was the problem is calcined clays is although it has been used in the past, it's a rather unknown material. So there was there were many knowledge gaps, and so that was the idea, to create a technical committee, inviting all the experts around the world, members of Rilem, working on the subject, and try to gather information covering all the aspects of the issue. So coming from the geology, from the mines, and also going to applications, calcination, industrial processes, everything until including durability. The state, the TC had a very, very good, I mean, we worked for 5 years. Every year we were doing more or less 2 general meetings, but also we had a very intense work in the work groups. We had 71 official TC members and a good balance between universities and the industry. So we had a very good representation of the industry, and that's showing the interest of the industry in this new material. And we created 5 work groups covering all the aspects that I have mentioned before. So clay exploration, process, cement hydration, applications, and also durability. As a result, we were able to publish a topical collection with 10 papers that are already, all of them, 9 of them are published. The last one is accepted, so it will be soon published. So we are in a good shape. Just for you to have an idea of those are the universities that were participating, also the industrial partners. So we're very, very happy with the participation of all the people. And this is the timeline of the work of the TC. We had our kickoff meeting in Delft back in 2018, and we're coming to the closure of this TC. In the last few months, we have been dedicated mainly to the preparation of the topical collection, but we have had very, very intense discussions within the work groups. Now I'm going to present to you some of the papers of the results that we have achieved in these different work groups. The first one was dealing with clay and clay minerals, and they were able to publish 2 papers. The first paper was mainly dedicated to the properties and geological considerations about the clay, and I mean, trying to understand the impact of the clay composition, of the clay type on the properties of the materials. And you may see the main findings are, I mean, we could really go in deep and check the differences between the 1-to-1 clays, so the calcinitic clays, and the 2-to-1 clays. We were able also to reach a consensus on a criteria for preliminary screening of the clays to be that are suitable for production of SEM. So this is very important for the industry, and also to have an idea of the availability of clay resources around the world. There was a second paper that was focused on techniques to characterize the clays, because this is a rather new material, so we need to see the differences. And the several techniques were evaluated and recommendations were made, especially in 3 main techniques like XRD, thermal analysis, and infrared spectroscopy. We all had an agreement in the sense that sampling is a very important point of the process. So you may carry out a full characterization, but if you're dealing with the wrong sample or the badly collected sample, that would be a big problem. Then we had the group 2 that was focused mainly on industrial processes, mainly calcination. So this time we didn't deal with grinding because I mean, that was too much to do, and that. And we had a first paper published. This paper was one of the top most downloaded papers in 22. And this paper was on clay calcination technology. So we were able to discuss in this paper the inside of the process of clay calcination, what are the reactions taking place, what are the things influencing this, the existing technologies and the availability. So it was very interesting, and also for the industry, it generated a lot of interest. You can see here the main findings, especially the characteristics of the process, CO2 emissions, thermal consumptions, different ranges, and also different technologies that are available for the calcination of clay. The second paper, which is already accepted, goes more into the history of the production of calcined clay, beginning in the 19th century, and discussing the current trends in the production of calcined clay, including the new projects that are developing. For instance, industrial trials like the one carried out back in 2013 in Cuba were discussed, but also the experience from Brazil, who has been systematically producing millions of tons of calcined clay in the last 30 years, so they were also incorporated in this paper. Then we came to the group of work group of hydration. In the work group of hydration, they had only 1 paper, but it was very interesting because it was addressing the hydration and mixture design of clay blended cements. I mean, in the context of the synergy between calcined clays and limestone and the impact of that. The main findings of this paper are very important, since, I mean, they were able to prove that in terms of phase composition, there's no major difference between cementitious systems containing calcined clays and the Portland traditional cement. So in terms of durability, this is very good because we can use the database that we have accumulated so far. But also, they were able to prove that kaolinitic clays are the most reactive ones, and they were also able to discuss the inside of the hydration reaction in this. Then we had the work group 4. That was a very productive group. It was in the area of application, so concrete, and we were able to produce 3 papers with a lot of acceptance. The first one was discussing the impact of fresh properties of cements and concretes containing calcined clays, the impact of superplasticizers, and the strategies to mitigate the increasing water demand that we were having there. So you can see here the key findings. I mean, mainly when you introduce calcined clays, you increase the water demand, and therefore you have to have a strategy to mitigate that so that you're not affected. We had seen already in the hydration group that we have a compromise on the one-day strength, and so the several strategies were also discussed in this paper to tackle that. Then we had a paper very interesting, also focused on mechanical properties of concrete made with calcined clays, where you can see here we were able to really assess the impact of the kaolinite content of the original clay in the mechanical strength of the material. So the higher the kaolinite, the higher the strength, the better the performance of the material. And also we were able to assess other properties of concrete like bond strength, containing calcined clays that are interesting also for industrial applications. Then we had the paper on the standardization. This is a paper, it was also decorated, awarded as one of the most downloaded papers. And then we were discussing here the current state of the standardization around the world, mainly concentrated in North America, so ASTM, Europe, EN, and Asia. So there was a big discussion on what are the compositions, how the calcined clays can be approved, what are the limitations for the use of cement with calcined clays and different conditions, and also what would be the perspective. As I said, this paper received the Outstanding Paper 23 award for materials and structures, so it was a paper very much downloaded. A lot of people are consulting this paper, and it's become some useful tool for the industry. And finally, we come to the final group, which is durability, where we were able to publish 2 papers. And in the first paper was, in general terms, how concretes containing calcined clays they perform in terms of durability. What are the main threats that you have? We were discussing carbonation, chlorides, and other durability effects. And so you can see here some of the main findings of this paper, especially the impact of the poor refining effect that is caused by the presence of calcined clays, and how this is impacting the durability, the properties of the material, and this explains why you see such a good durability in these materials. Then we had a second paper, which is more focused on chlorides and chloride-rich environment, which is the best, this is the best use for cement containing calcined clay because of the high impermeability they have, and that chlorides do not really go into the system. So you can see here, it was very interesting because were able to discuss, and there are several groups working on that worldwide, and we were able to discuss all the results and present them in this paper. So also we were able to see some cases, so compare lab analysis and natural exposition cases, like with some exposure sites in Cuba, but also in India, and compare results and reach interesting consideration. So I'm coming to the end of my presentation. So you see, it has been 5 intensive years, lots of people dedicated to the work, very interesting results. And there's the papers that we produce, we were able to meet the goals that we set ourselves at the beginning. Remember, we were talking about creating information or gathering information or compiling information that could serve the industry to, embrace the technology of calcined clays and fill all the information gaps that was available. We were able to see the different clays that were available, and we were able to reach consensus on criteria to screen and to determine which are the right clays. We also gave choices in terms of technology for clay calcination. There are several technologies. We were able to evaluate them all. Also, in terms of product, we could discuss for instance, the impact of chemical admixtures in cement and concrete, and to see also the impact on hydration. And finally, we were able to really discuss the impact of the presence of calcined clays on durability of these materials. So it was a very good work. And I take advantage of my presence here to thank all the members of the TC for the dedicated work and the results that we have had so far. So having said that, I come to the end of my presentation. Thank you very much.